So I've chosen the two cars braking problem for the physics assignment. For this problem, you need to know three different equations. You need to know that V final is equal to V naught plus acceleration times time. You're going to need to know that the change in x is equal to V naught t plus 1/2 AT squared, and that V final squared is equal to V naught squared plus 2a times the change in x. So these are the three equations that you need to know in order to start this problem. So for this first question, we know that we are trying to solve for time. Now, if we're trying to solve for time and we are given a velocity as well as an acceleration, we know that we're going to use our first equation. Now we know that V naught is 0, okay, and that our final velocity in this problem is going to be 25 meters per second. So if I have 25, okay, is equal to 0 plus negative 2.05 times t. If I rewrite this, it is 25 over negative 2.05 is equal to t, which means t is equal to roughly 12.19 seconds. So that's how you do question number 1. So for question number 2, we are trying to find how far the lead car goes before it comes to a complete stop. Now, a couple things that we know. We know the time, we know the velocity that it was going, and we know the acceleration that it was going. However, we don't know how far it goes. That's why we're going to use equation number 2. So we're trying to find the change in distance, right? So in order to solve that and find out how far the car traveled before it came to a complete stop, we're going to have to rewrite this equation. Now we know V naught is 0, so that completely eliminates the V naught t part of this equation. So if we look at it, we have change in x, which is going to be our distance, okay, is equal to 1/2 AT squared. So there's the equation that we are working with. Now, if we plug in our numbers for this equation, we have the change in x is equal to 1/2 times negative 2.05 times 12.19 squared. Now, if we plug that into our calculator and we click enter or solve, we know the car traveled 152 meters before coming to a complete stop. So for question number 3, we are trying to find out the minimum acceleration for the chasing car. So what equation are we going to use? We have 3 equations, and we're trying to solve for acceleration. So because of that, I think we should use the third equation. Now, you might be thinking, well, why not use the second equation? Well, we don't have time, so we can't use that one. And we're trying to solve for acceleration, but we don't have everything that we need in order to solve that with number 1. We need a little bit more. And so if we use this third equation, Vf squared equals V naught squared plus 2a times the change in x, we can figure out the minimum acceleration that the chasing car needs in order to not hit the first car. Now you might be thinking, well, there are 2 unknown variables in the question right now. We don't know a, we don't know the change in x. Well, to solve for change in x, we can say that the distance is equal to 152, which is how far the first car went before coming to a complete stop, plus the 39 meters that the chasing car was behind the lead car. Okay, and this gives us 191 meters, okay? And we're going to plug that into our equation in just a second. Now, we're trying to solve for acceleration, right? Well, let's rewrite this equation algebraically in order to find out what the acceleration is. So I can see that A is going to be equal to VF squared minus V naught squared all over 2D, or 2 times the change in x, okay? Now if we plug in our values for this equation, we can see that A is equal to 0 squared minus 30.4 squared over 2 times 191, okay? And if we plug this into our calculator, we get the total of A is going to equal negative 2.41 meters per second squared. So in question number 4, we're trying to find out the time it takes for the chasing car to come to a complete stop. Now remember, in question number 1, we did this exact same thing, but with the lead car. So we're going to set it up the exact same way. We're going to use the first formula. So we have VF is equal to V naught plus AT. V naught is going to be 0, so really we just have VF is equal to AT. We plug in our values, so we have 30.4 is equal to negative 2.41 T. Now if we do this algebraically, we see that 30.4 over negative 2.41 is going to equal T, and then we find that T is equal to 12.6 seconds. Thank you for watching my video. One of my favorite physics jokes is distance raptor over time raptor equals velociraptor. And here is my pathetic attempt at drawing a velociraptor, which is a dinosaur. And so that is my video. Thank you for watching. Please give me a 100.